Can you hear me?
All right, so let's move forward with respect to the routing now. So in routing from the FMC, from the GUI part, OSPF, BGP, and RIP. These are the three protocols which are directly supported. And EIGRP, ISIS, these are indirectly supported. That means you do have something called as a flex config.
How about static?
Sorry?
How about static route?
Yeah, static is common. That's
supported
static
as well.
Yeah, static is common. That's no problem with static. All right, so now these two things are not being configured in your production, nothing to worry. And since this configuration becomes pretty much complicated, so that's the reason no one will configure. And in the production, you won't see EIGRP most of it anyhow. All right, so EIGRP and the RIP, you do not see most of it. ISIS, these are the three things which you might be seeing: OSPF, BGP, and ISIS. But OSPF is the widely used one, so you have to be pretty good with that OSPF, how you configure the OSPF, and what are the different behaviors or different SLAs databases for the OSPF. That's what you need to have that knowledge about it with respect to the OSPF, because you as an firepower defense threat defense administrator, it will if you do not understand how the OSPF actually which area you belong and how you have to configure, then it will be pretty much difficult for you to understand like configure things and troubleshoot the things. So OSPF, I don't think so. BGP will be a pretty much problem for you because that is with respect to the ISP. Mostly you will be just having a neighbor relationship with your ISP. That should be pretty good and enough. But with respect to the OSPF, that's where you will have a problem, lot of problems. If your production side is dealing with the OSPF areas, and as a backbone of the OSPF, they do have a OSPF backbone. So pretty much what I want to say is that if you do have a large environment, then if they are using an OSPF, definitely there will be a area 0 which will be serving as a backbone. Now they might be connected to the different areas, and now your FTD is over here, and you want to make sure that your FTD is being connected to the area 0 to the backbone, or there might be another branch over here instead of here. Now you are in this different area. So this area is a area 0 and this area is a area 1. All right. So until unless there is a device that is in ABR connected, so you will get the routing information. So you have to understand this one. So now in a certain scenario, what happens is like you do have another branch here, another branch here. You do have your FTD here. This is your branch. Now this is your area 0. This is your area 1. And this is your area 2. Now you do not have any connection to the area 0. That means you do not have any visibility of the OSPF topology. That's where you have to understand now. And the important thing is that you have to make sure that by any means you have to connect to the area 0 of the OSPF. So currently this guy will be getting details because here you do have an ABR. So that's the reason he will translate that databases, routing details and everything. And this guy will get that one details. But since this is ASBR, he is not going to translate anything. All right, so that's the reason you will not get any information, because he will get information. He has a full reachability until here, but he will not forward you the information here. So now you have to get that information. In order to get that information, there is something called as a virtual link. So once you connect to the virtual, using the virtual links, once you connect to your backbone area 0, the area 0 will start sharing the details now. Now at this point of time, you will have a full visibility of your OSPF topology now.
Why do we need virtual link?
If your FTD is located in a different area. So if you see that my area 1 is over here and area 2, I am located in area 2, and the branch which I am connected to, that area is not even directly connected to the area 0. So I am connected to a ASBR, AS boundary router.
Okay.
So what happened with the ASBR is that ASBR will take the information, but it will not forward you the information. That's the issue here. Because that's how it is been designed. So he will not share the details, but you need the details, right? In order, so for example, this is your data center, which is located in the backbone, and you want to communicate because you do have a sensitive applications or applications which your users need to access those. But as an FTD administrator, they said you that, okay, the data center, we do have a data center in area 0, but you're located in area 2. But they will say that from the data center for your branch, the routing has been done. So it's your job to configure the routing number 1, and you have to make sure that you're connected to the area 0 using the virtual link.
So why can't we use why can't we use the interface? Why can't we communicate through the interface?
Because OSPF is a link level protocol. So if you are using an interface, who is directly connected to my interface here? I'm going via this branch, right? And this branch is acting as a ASBR. So that means he is not even directly connected to area 0, so he will not translate anything.
So does the virtual link connect directly to area 0?
Yes, when you connect the virtual link, this virtual link will help, the area 0 will help you to provide all the details. It will provide the databases and everything, all the details.
The route updates.
Yes, required to communicate.
So once the FTD receives the route updates, it will now send the actual user traffic through the appropriate interface based on the route update received from the area 0.
I did not understand your question.
Let's say your FTD has 4 interfaces. Okay.
Okay.
And is using the virtual link to receive route updates.
Yes.
Now, once you receive the route update, that tells your FTD what interface it should send also traffic to, right?
Whatever the interface which is able to communicate with your data center.
Okay.
It can be any interface. It doesn't mean that it should be outside only, no. You might have an MPLS network and you do have another interface through which you are able to communicate with your data center. Yes. So whatever the interface by which you are able to communicate, that's where it will automatically, on top of that network or top of that particular route, it will build that virtual link. So basically, this is your FTD, right? This is your router, this is your router, and this is your data center here. Now, if I build a route, this is the outside interface, right? So from the outside interface, I'm able to communicate with my DC, right? I'm able to ping to my DC. That's where on this particular path, your virtual link will be created. Now, for example, it is not an outside interface. This might be a different interface. For example, it will be like an MPLS interface. If you are able to communicate your area 0 on this interface, it will build that virtual link on this one.
So the bottom line is that the FTD has to have direct connection with area 0.
0, yes. Because this is, you need to understand this one because you are the one who is going to be in trouble if you're not able to communicate. So the production will say that, okay, Mike, this is the area 0, this is which is a data center. We have configured everything from the data center so that they can communicate with you. So they will provide you with the details saying that these are our requirements. This is what you have to configure. So you have to go ahead and configure. But
would they give you the information of the virtual link?
They will definitely give you all the information in your production.
Okay.
So because you are not a designing expert, all right, so you're not designing. So designing is being done by someone else. Configuration is being decided by someone else, and they just want you to configure these things. All the details are pre-allocated and they will be just providing you the requirements, and that's where you will be configuring things. So your role is a FTD administrator. So now once you get the details, you have to understand what's actually happening over here. And if you see any faults, you have to report back to them saying that, okay, I do follow this. I do have a question regarding this one. Can you please give me an answer for that one? Right. So because you are the administrator of the FTD, if anything happens, you are the one who will be contacted in first place. So you need to understand OSPF in a pretty much detailed way in order to troubleshoot the problem, because OSPF is widely used in the protection. All right.
Yeah.
Let's go forward now. So at this point of time, I should have the SSH connection. So I will take the SSH connection and I will move forward. Right. So good. So let's move to device management. Now coming to the BGP also, there is not much in the BGP with respect to the FTD, but the only thing things become complicated if your company is a service provider. So that's where the things become little complicated if you are a service provider. But if you are a business, then business production or something, nothing to worry about it. Now, another thing with respect to the routing is that I do have an FTD here. According to my topology, I am running BGP at the outside, RIP on the DMZ, and OSPF on the inside. Now, I can redistribute the routes. If I like, I can redistribute OSPF into BGP and BGP into OSPF. That's perfectly fine. But when I am redistributing into the BGP, which is the outside and connected to the ISP, what happens is that whatever the OSPF routes you do have right here, that will be redistributed into the BGP, but your ISP is not interested in getting details of your prefixes, so it will reject that prefixes. So it's not a good idea to do a redistribute between your ISP and your own network. So instead, what you can do is that another solution for that one is that from the FTD, you can send that OSPF domain at default route. So once you send the default route, what happens is like they will just send all the traffic to you by default. If they are unable to find in the network, if they don't have any route, they will just send that route to your FTD. And the same implies now RIP is within my network. Now I can go ahead and do the redistribution. That's not a problem again, because these both are located inside my network. So that shouldn't be any problem. But the only thing is that if you do have a multiple prefixes here and you do have a multiple prefixes here, you do have a large database of your routing. So routing your database will be very large. So you don't want that problem issues to arise. Like if you don't want that problem to be arise, so what you do is that you can just send the default gateways to the RIP and default gateway to the OSPF. In that way, what happens is like they just stay inside the domain. The prefixes they learn in their domain, that stays over there. For example, I am learning only 10 prefixes over here. I am learning 20 prefixes. That means the size of my routing table will be this much. That's it. So this will help you to reduce the CPU usage, the memory, and the flash of your routing. Reduce the size of the routing table. So whenever you are configuring things, these are the different things which you have to take care about in the production, because that's where the storage size and everything matters over there. And you are the one who is going to troubleshoot, and you don't want these many routes to be shown here saying that, okay, I don't want this route because I don't actually need it. So get the routes which you actually need it. Otherwise, if you don't want to get any routes, doesn't matter, because they are going to share all the details. All the details will be located on the FTD. So prefixes, 10 prefixes coming from here, 20 prefixes coming from here, all the 30 prefixes you can see on the FTD. So there is a full visibility on the FTD, and you don't want any visibility on the OSPF domain or the RIP domain. So these are the certain things you have to take care about, consider things, what actually you want to do, how you actually want to plan. But basically your job is to just to do the configuration which is been provided for you, but understand that configuration and ask question why we are doing this one, why can't we do that one. All right, so let's move forward with that one. So I will go ahead and click on edit, and I will go ahead and configure my OSPF. Click on routing. Now static is a pretty straightforward. If you want, I can show you the static one. Click on static, and I want to provide a default gateway towards the outside. So I will just go ahead and click. I will say that I want to provide the route on the outside, select the outside interface, select any IPv4. Because I want to give a default gateway. So this is how you will give. This is the 0/0/0. You see that 0.0.0.0/0. In
So
any
you want
IPv4.
default to go to outside interface.
Yes.
Right.
So any routing, any prefixes which are not available in the routing table, it will go to the outside interface. And gateway, if you want to create an object for the gateway, you can go ahead and create, or if you want to directly provide, said, okay, my default gateway will be this one, just write down the name, and that should be fine. So that's all here. But if you want to give a static route, for example, you see that my FTD is able to communicate with this edge router, but he's not able to communicate with my switch. So in that case, what you can do is that you can do the same thing. You can create the object and define the network to which network you want to go. So once you define that network, select that network and provide the next hop. And the next hop will be 172.16.2.254. And here the actual object, that's the actual subnet. You will provide the subnet here, and you will say that you're providing that route into the inside interface. So basically this implies to the same thing which we used to do in your ASA, that says that route inside 172.16.3.0 with the 255.255.0, and the gateway will be 172.16.2.254. Next hop. That's the same thing here. So inside route, this is the route template. Now inside prefix, and then the default gateway. Sorry, not next hop. Provide the next hop. So that's static is a pretty straightforward, as you are pretty much experienced. So that's why I'm not going with the static. So my focus is on the OSPF. Basically, I will select, I want to enable the process ID number 1. Area, yes, my area is 0. If you see my topology, the area is 0. All right, so I will just remove these things so that it will be pretty easy. All right, so area is 0 at this point of time. So I will go ahead and configure my area, click on add, and area ID as 0. And process ID should be 1 because I have enabled the process ID number 1 here. So be careful with that one. Now area type, currently I'm using the normal area type. You do have the stub and NSA too. And I will select that available network, whatever the interfaces network you want to define. Since OSPF is linked to link, I said that OSPF is linked to link, and my prefix is 172.16.2.0. That's what I have to define. So I click on this object, and I will say that OSPF inside, and I will define the network 172.16.2.0/24. Click on save. Okay. Click on refresh, and I should see OSPF inside. Click on add. Authentication, again, if you want to do the authentication, plain text or MD5, you can go ahead and provide that one. But now what this implies is that now this statement says that, okay, I have enabled the router OSPF1, process ID number 1, and next I am saying that this is the one network. In this network, I have defined 172.16.2.0, 0.0.0.255 with area 0. So this one translate to this one. Pretty simple. Okay, within an area 0, I am just defining this prefix. Next, stubby NSA. Now, stubby and NSA, these are the two different things. Normal stubby, not much different, but NSA is pretty much different now. What do you mean by NSA now? So now I do have my data center over here, which is connected to my maybe branch 1, right? And this one is connected to branch 2, and this is connected to my sub branch. So these are the this might be the headquarter 1, this might be the headquarter 2, which are large sites, and this is my small site, site 1. Now the NSSA, the reason why I will be using the NSSA is that I don't want the details of this particular site to be shown on my data center. So I will configure this particular area into a NSSA, not so stubby area, NSSA type. So what it will do is that it will reduce the OSPF databases. So currently, if I say this is the area 0, 0, 0, and area 1, right? So currently in this OSPF, it will generate a different types of databases that will be the type 1, all right, type 2, type 3, and type 5. So these are the different databases that will be generated, but type 5 will be generated only if you do the redistribution or which are from the inter area, different area. Since I do have a different area, that's why it will be generated. But behavior of OSPF is entirely different when compared to the databases. It's like pretty much, if you want to understand, actually, it's pretty much complicated in the understanding way, because how you configure the OSPF and how it behaves is entirely a little bit different. So now what this NSA database will do is that once you configure this site in NSA, it will say that, okay, I will be not creating the type level of what do we say, the different databases that are type 3 and type 5, it will just create the type 7 database. So to reduce the level of databases, that's where you will configure the NSSA. So if you say that your FTD is in the NSSA, that means you are not able to communicate with this one. So again, it's another problem because this is the NSSA. Now, since this router is acting as a directly connected to the ABR, that means directly connected to your area 0, this will be acting as an ABR, area border router. So that's the reason he has a capability to translate your level 7 database into level 3. Right, so these are the different things which are very much in advance. To understand this one, you have to totally learn the OSPF. So, but anyhow, but I'm just showing you the details. So I'm just trying to make you understand that if you are dealing with the OSPF is not pretty much easy things which you can go ahead and configure. So it's pretty much complicated over here. So currently I'm just creating a normal, or I can go ahead with the stub or go with the NSSA. Not so stubby area. Now, since this one is the area 0, NSSA shouldn't be any problem.
Which interface is NSSA? Which device? FTD?
FTD. It's not about the interface, AJ. So it's like this is your FTD. The OSPF is a link level. So basically, this link will
you
be
can. Yeah, is the link. I mean, it's
inside.
In the way, it's
inside
the interface, right?
Yes.
Because only if you have two interfaces on that zone, only those two interfaces will partake in whatever area you define.
Yes.
And you can have another interface on the core side.
Yes.
And you can make that interface partake in another area, right?
Yes. Oh, that's why you need to have a pretty good information about the OSPF with respect to that whenever you're configuring. So the reason I have told you so much things is like so that you have an idea how complicated the OSPF, and when you're dealing with the OSPF, how pretty much you have to be careful with that one.
Yeah, but what I don't understand is if you deploy your FTD to be in area 0,
Your voice is very slow.
Can you hear me now?
Still slow.
How about now?
Yep, all good now.
So what I don't understand is if you define your FTD to be in area 0,
yep,
why will you choose area type not so
no, I will not be
NSSA?
selecting now.
Yeah, okay.
I'm just giving you an option, saying you that you do have an option to select that stubby area or not so stubby area. All right, so once you selected the interface, and I also talked about the virtual link, right? If your FTD is totally out of context with respect to area 0, this is how you will create the virtual link. You will select who is the peer router, provide the address of that peer router. Hello intervals, don't worry, keep it default, that's it. So you're basically saying that who is located in area 0, provide that IP address to that one. Once it try to communicate with that IP address, he is able to reach, then it will automatically create a virtual link and it will share you with the different routing databases for you. So this is where you will be configuring your virtual link. And click on OK. Right, so click on Save. So I will go ahead and deploy this one. Then until that is been deployed, I will go ahead and deploy the RIP also. Right, deploy and deploy. Right, so until that is been deployed, let's go to device management. Now let's look about the RIP now. So this is my DMZ network. So my router has been pre-configured with the RIP, and also my edge router is being pre-configured with the OSPF. OSPF, you see that it's been configured, and I will go with the RIP also. Right, so I've also configured the RIP over here. So routers are pretty much pre-configured. I just need to configure on the FTD. Now, another one important thing which I forgot to tell you, that's regarding the DR and BDR. So DR is a designated router and BDR is the backup designated router. So in the OSPF, definitely whenever you do the configurations, any one device will become as a DR and another one will be becoming as a BDR and the remaining will be DR others. Now, the reason for this DR and BDR is that DR is responsible to get the details from all the routers and propagate to all the routers. So basically, if you do have this one in a shared segment now, any one router will become a DR, another one will become a DBR, and this one will be the DR other. Now, with this type of scenario, what happens is like instead of sending the prefixes to this guy, again, if I have another guy, then I will be sending to prefix to another guy. Now, the router 1 has sent that one, router 2 will do the same thing. He will get the details and he will say that, okay, I get the details from the R1, he will send it to R1, he will send it to DR, that is R3 and R4. And he will also send it to R3, R4. Again, the R3 will do the same thing. I got the details from R1, R2. These are the details and these are my details. So there is a lot of congestion on these particular links. So to overcome that one, that's where you will be OSPF will be selecting the DR and BDR. Now the role for this DR and BDR is that whenever they have the adjacent, okay, neighborship, right? Once they have the neighborship, what they are going to do is that all the routers will share the prefix to DR. Okay, so in this scenario, this is router 1, 2, 3, and 4. This is DR. This is BDR. Now these two are DR others. So what these will do is that it will form a neighborship 1 with DR, and it will also form a neighborship 1 with BDR. Only two neighborships, but it will not form the neighborship. It will show that yes, it's a neighbor, but neighborship will be formed with these two only. Again, the same thing, this router also will do the same thing, form the neighborship with this guy and this guy. Now, what happens is that if he wants to share the prefix, he will share the prefix to this guy, and he will also share the prefix to this guy, only two, that's it. And he will also do the same thing, he will share the prefix with the DR, and he will share the prefix with the DR, only two. Now the network congestion is very less, came to almost very low. Now the reason for the DR and BDR is that in case the DR goes down, this will be promoted to as a DR now. So it's like a backup. So what happens in this scenario is that if there is another different protocols, the topology will take topological changes will be done. That means automatic convergence will take place, and due to which that one the advertisement flooding will start. But with the OSPF, what happens is like as soon as the DR goes down, that BDR will become the DR, and it will reduce that convergence. So routers already know that, okay, I do have a neighborship. I'm still able to communicate with the network, so they will not send any updates. They will just stay for that. They will not do anything, these routers. So once this BDR will become the DR, promoted to DR, it will just send one update. He will announce that, okay, I am the DR now, and this particular router has gone down. So still these are your updates, so keep it learned. So a lot less flooding has been done on this one. So that's why pretty much OSPF, when you configure again and again, that's why I'm saying that you have to be pretty much careful with that one. All right, so now let's go and see that I have already deployed. So that means my edge router should get the name relationship. See that I do have a name relationship with 4.1. I don't have with the I'm able to let me go ahead and see the configuration because I think I might have done something wrong. Go to the routing. All right, OSPF going to the area 0. Yeah, define the selected network 172.16.2.0/24. That's a normal. That's pretty much good. Okay, I did not define the interface. Click on add. Should be on the inside interface and just keep the default. That's it. Never, no need to worry about that one. All right, so area and the interface. So within the area, you will define that the process ID and this one, and this network. I think I will remove that network and I will see, because it's a link level, shouldn't be a problem. Because I defined the interface that should do the job. Click on save. Click on deployment. Let it deploy. So we will configure that one. We'll troubleshoot that one later on. But basically that should come up. Now let's move with the BGP. Again, with the BGP, you are not going to redistribute your OSPF into BGP. You're just going to configure the BGP name relationship, and your ISP by default, he will be sharing all the prefixes of the internet and the default gateway. So it's up to you whether you want to accept all the prefix or you want to just accept the default gateway. So basically, most of the time in the production, you will only accept the default gateway. You don't want any routes from the internet. You're not interested in that one. So I will let's go ahead and click on edit.
How does
All right, with the BGP now, I will go to the same thing, routing and the BGP. First, select on the BGP, enable that BGP first, number 1. Once you enable, what is your AS number? My AS number is number 10. Click on save. Once you save this information, now basically I'm doing the IPv4, so that's why I will select the enable the IPv4. And who is my neighbor? I will go to neighbor and I will add the neighbor. And my neighbor should be 150.1.7. My neighbor is 86. Enable that one. Once you enable what is the remote AS, that will be 100, and that should be done. Now, if you want to advertise, this is where you will advertise your prefixes. Not here. These are with respect to your advertise intervals. These are filtering the routes. So basically, I said that ISP is going to share all the prefixes from the internet. So if you don't want to get to all the details, you can assign the access list over here and click on OK.
And go to advanced.
Yep. That's for the authentication communities. So BGP advanced. So since you're not an ISP, so you shouldn't be worrying about this one.
So we cannot define what we want to advertise on BGP?
Yes, we can. But there is you see that networks here? This is where you will be defining. If you want to advertise, this is where you will advertise. So you will create that object here and you will define the network. And if it's a /24, you will define that one as a /24. Or if it's a /32, you will define as a /32. Right. So basically, I did nothing. I just went to the BGP provider, enable the BGP, provide the AS number. I went to the IPv4 address family, enable that one, and I provided the neighbor and the remote AS. And since there are no networks here, so I'm not worried. And click on save and deploy. Deploy and deploy. Now with the OSPF, I will also show you next week regarding the virtual links. I think I have already showed you the virtual links. So if I will say that if I am able to create any good lab for the OSPF, I will go ahead and create, otherwise no. And do let me know if you have a very good idea of OSP, then only I will go ahead and plan for that one. So let's go to the BGP. All right, so it's happening now. My BGP membership is up. So IP BGP. Yep. See that I'm not sharing any prefixes, but if I go to my FTD, show BGP summary, you see that my ISP is sharing one prefix, and that is show route. If I say show route, and you see that my default gateway. So basically, my ISP is sharing only default gateway for now. But in your actual production, your ISP will be sharing all the prefixes. It's up to you which you want to get it or not. So at this point of time, if I go ahead and if I say that ping 150.1.7.86, I should be able to ping to my ISP because that is directly connected. But since I do not have any network on my ISP, so I will just create one network on that one. And router BGP network will be right. So I have advertised that neighbor. So I have advertised this 10 network. But if you remember that I have already shared the default gateway, so that means I no need to advertise this one. I just advertise so that I want to see the reflection on my FTD. So still I did not receive that one 10.10.10 prefix, so it should be receiving. So just to show you that how that it will reflect whenever the ISP is sending you the prefix, it will automatically get into your routing table. But the only thing is that you have to place your access list in order to stop those prefixes. Otherwise, it will be just flooding your routing table. Right, so that was your BGP and the OSPF. And let me know if you are good with the OSPF. I will plan a good lab for the OSPF. So my ISP sharing two routes, two prefixes I can see over here. But anyhow, I do have a default gateway. That means I do not require this one. Even if I want to reach this one, it will automatically use this route.
Yeah, the default takes care of
Yep.
that.
The only thing I want to show you that if any prefixes have been advertised, it will definitely, you will get those prefixes.
And why do you?
If I go to see the advanced, you see that in the advanced, I can provide the router ID manually if you like. So I can go ahead and say that, okay, 0.0.0.1. It's up to you, router ID. If you want to provide it manually, you can go ahead. Basically, by default, log agency changes, that should be enough. And enable default information routing. So basically what I'm saying that on my OSPF, I don't want to redistribute from this one to BGP or BGP to OSPF. So that's why I want to send a default gateway to my router. So if you want to do that one, you can just send a default route. That's it. You don't need to advertise or redistribute your BGP and OSPF in order to have a communication. Click on OK. And here you see that OSPF's role selection, ABR, ASBR, ABR, and ASBR. So this is what you have to select. But basically, whenever you're dealing with the FTD, it should be most of the time ABR or and ASBR. It can be anything. It has a capability, so you can select both of them. And area we have already seen. Redistribution, again, nothing. Click on add. And you want to redistribute into BGP. That is the process ID 1. What is the AS number is number 10. That is what I am hosting on my BGP. And use subnets. Definitely 100% you have to use this subnet. Otherwise, the OSPF will not redistribute your routes. You have to select this one. Click on OK. Please confirm that configured AS number exists. That means AS number 10 is exist on my particular FTD. So that's the only redistribution. This is the OSPF, and next week we will go ahead with the RIP. And once we finish up the RIP, we will continue with the policies. So any questions so far? All right, let's start troubleshooting the OSPF now. So first I will go ahead and check my edge router. So what is the configuration? Do show IP interface brief. That's all good, looks good. And do show run section OSPF. All right, so I have advertised the network, that should be good. And do ping 172.16.2.10. That is my FTD inside interface, so it is not able to ping. So let's troubleshoot that one now. I go to my FTD now. On the inside interface, you see that my IP address is not correct. So I'll go ahead and click on edit. And I will just go to IPv4, click on 2/10, should be okay. Click on save, deploy and deployment. So now once I deploy this one, my OSPF should be up and running. Right, so click on deploy, don't worry about it. And now it's deploying. All right, so I have corrected my interface IP address, so it has been pushed. So now let's go to the edge router, and you can see that my neighbor relationship is up and running. If I say that do show IP OSPF neighbor, I should find now two neighborship. One is with my switch and another one with my FTD. And if you remember that we have given the neighbor relation router ID as 0.0.1 for FTD, so that's why. And now you see that my 4.1, that is my switch, is acting as a DR, and my FTD is acting as a BDR. Right, so now let's go to the FTD device management. And also I will check the routing database. If you remember that we have sent the default route, so you can see that my OSPF is also sending the default route. So if I go to my FTD, so if I go to my routing, on the OSPF, I said the role will be this one. If I go to advanced, this is the router ID which I can see, and also I said that enable default information originating. So what I would do, I would just disable that one, click on OK, click on save. And also what I'm going to do is that I've already redistributed the OSPF into BGP. So I will go ahead and redistribute the BGP into OSPF. Select the BGP within that one IPv4 and go to redistribution, click on add. Connected protocol should be OSPF, process ID should be 1. And I don't want to match anything, I want each and everything. So I'll click on OK, click on save, and click on deployment. FTD, deploy and deploy. All right, so my deployment is being successful. So I redistributed the OSPF into BGP and BGP into OSPF. So first I will go to my edge router and I will say that do show IP route. And I should see 10.10.10 network, which is from the BGP. See that E2 external route. Right, so and I've also removed the default gateway, and you can see that the default gateway is also being removed from the OSPF. And now if I go to my BGP and if I say that do show IP route, and here I can see that 1, 2, 3, and 4. So these are the networks which I have advertised on my OSPF, and I can see that all the networks have been advertised. But basically what you have to do is that anytime you need to only configure you have to make sure that you do not redistribute from the BGP and BGP to the OSPF. The only thing you have to do is that whenever we are configuring the BGP, we send the default gateway. So anyhow, ISP is going to share the default gateway. That's good and fine, but I don't want these prefixes to be advertised on the ISP network. Anyhow, they are going to reject those prefixes. But instead of that one, what I can do is that I can just send the default gateway. So let's go ahead and configure that one now. So what I would just remove the redistribution, and I will just generate the default route, which is on the OSPF. And I'm already getting the default route from the BGP, and that shouldn't be a problem. I would just send the default gateway as usual, click on OK, and I will go to redistribution and I will delete the redistribution, click on yes, click on save. And from the BGP also, I'm going to remove the redistribution. So under BGP, go to IPv4 and go to redistribution, delete, click yes, and click on save and deployment. Right, so now this is being deployed. So at this point of time, what I'm going to looking is that I should get a default gateway from my ISP, and I am sending the default gateway to my OSP here. So if my edge router wants to communicate, it will utilize that default gateway. So let the policy being pushed. Right, so policy is being pushed. Let's go back to my edge router. So before you see that there was no default route, so do show IP route. And now it has injected the default route, and it has also removed that external route which is coming from BGP. Now if I go back to my BGP, sorry, not BGP, I will go back to my FTD, and if I say that show route, and I should see that it's a default gateway, default route which is getting from my ISP. Now next thing is that we will go ahead and configure the RIP. So I will go to device management. Routing. So enable that one. Was it 1 and 2? And again, I'm going to generate the default route in here also, so that it will be pretty easy not to redistribute the route. Now again, the network. So I don't have any network, so I will go ahead and click on object, and I will say that with network, and the network should be 40.1.1.0/24. Click on save. Click on refresh, and should see the RIP network. Click on add. That's it. So click on save and deploy. Deployment, deploy. Right, so my policy has been deployed, so that means my router has been pre-configured for that one. So the only thing is that I need to verify that one in the FTD, because I am not sharing any prefixes from the FTD. I'm only sharing prefixes from the router. So on the FTD, I should verify that I should see the prefixes 1.1.1 network. If I go to my FTD and if I say that show route, and you see that the RIP has sent me the summarized route on the DMZ. So at this point of time, if I say that ping 1.1.1.1, I should be able to ping. If I ping 1.2.2.2, I should be able to ping. So now if I go back to my RIP router, that is the DMZ router, I should see the default gateway, show IP route, and you see that default route is being not propagated. So let me check and verify that one, why it did not get the default route. I'll go back to my Windows, go to device management. Back to routing. And generate default route, that's good and fine. So we have already selected that one, that shouldn't be a problem. Send version 1, but I am running version 2. So click on version 2, because on the router I'm running version 2. Click on save and click on deployment. And deploy this policy. Let's wait for this policy to be deployed. So our policy has been deployed because it was sending version 1, but my router was configured as version 2. Let's go to server, and if I say that show IP route, and now I should get a default route from the router. So that was your OSPF BGP redistribution, OSP redistribution, and the router.